This is the midterm review for special problems in animation. We'll go over some terms and definitions. It's important to know the difference between computer hardware and computer software when you're talking about what you're doing with the computer. The physical equipment of the computer, anything you can pick up and throw, anything solid, that is computer hardware. But the programs and data that run the computer are called software. That's the virtual information. And you usually would talk about writing code or using a program, but it's not something that you can put in your pocket and walk away with. Vector graphics. When we're working with the After Effects program, you have the option of using raster graphics or vector graphics. The output, of course, is always going to be raster, but if you have vector graphics that you've put in one of the layers in a comp, the vector graphics will be scaled so that they're completely sharp at any magnification. And this is something important for detail. So vector graphics uses mathematical formulas to describe the shapes in the file. And when you use fonts, this is very important because if you zoom in, the fonts will be scaled and they will not lose definition, and they look the same at any resolution. But raster graphics, the image is composed of individual pixels on a two-dimensional grid. The scaled fonts appear jagged and fuzzy, and you can see that happening here because this is a raster graphic on the right, and when you zoom in, the anti-aliasing makes it look fuzzy, and the fact that it's made out of boxes, little dots that are square, and that is what rasters are, makes it look very uneven. It's unattractive. This is another example of what happens when you're talking about raster graphics. If you zoom in on an image, you can see the individual boxes or dots, the raster map of pixel dots that make up the image. So a picture element is a dot of light on the screen, and that is what the little squares are. The raster map is a grid filled with pixel dots to create the picture. In the raster image, when the object is magnified, the dots become larger and more apparent. So the resolution or number of pixels per inch determines the clarity of detail of the image. This is why it's very important to know how many pixels you are using in your image, and this is why we have presets, so we will be able to control the number of dots per inch, either horizontally or vertically. And once again, here's vector versus raster. This is a vector rectangle that I drew in Photoshop, and here's a rasterized rectangle that I duplicated and then rasterized. And when you zoom in, you can see the difference. I transformed the scale and made both of the squares bigger by the same amount. And although the vector image is sharp and clean and remains detailed even at this magnification, the raster image is much fuzzier and it has halos around it, so the colors start mixing. The aspect ratio of an image determines the shape of the image. So the proportion of the width to the height. So often you will talk about 16 by 9 or 4 by 3, and those are aspect ratios. You divide the width by the height to make sure the units are the same. You divide the width by the height, and then you can tell what the number is to use to describe that particular aspect ratio. So a 2 by 1, you can see that rectangle is very wide and not as tall, but a 36 by 24 or 4 by 3, there's a complete different shape to it. The persistence of vision, this is the particular way that we see things. And when you look at images in sequence that change quickly, the image will persist on the retina until it's replaced by the next image. And that is interpreted by the brain as smooth motion. This concept, this idea, is the basis for the movies and video and animation that we see today. So this is an example of phenakistoscope or a phantoscope, an early type of animation that was invented back in the 1800s, where you would spin the disc and you would look through the slots into a mirror. So this would be facing towards the mirror. And as you're looking through the slots into the mirror, you would be seeing this image that would seem to be moving. And that was because of persistence of vision. A keyframe is a frame which shows an important change in position or appearance. Used as a guide for subsequent action, it's used in storyboards to tell the story. So we've used keyframes in our storyboards. It's like our shorthand outline of the animation. And here is a storyboard. This would be an example of what you would do for a storyboard. A visual outline of an animation or movie using keyframes to describe the action, containing notes about dialogue, camera moves, and editing. So the timing is very important. Often there's a lot of information about how much time each of these scenes will last, or which particular SMPTE or time code would be the beginning or end of that particular comp. In-betweens are the frames which fill in the gradual changes between keyframes that create the illusion of a smooth movement. Now in computer animation, we have the automatic keyframing, that it's actually done by the computer, so you don't have to think about it. So this would be at the top, you see the bunny, the different set positions, the poses, and down below you see the in-betweens that are put in the poses, so you can make the smooth movement. A scene, which is an action unbroken by any change to another visual, is like a sentence in regular speech. So if you were writing your speech in speech class, or you're writing a story in an English class, you would have a scene, which would be a sentence, and a sequence would be a paragraph. So you would have a sentence that made up the paragraph, but then the paragraph would be a series of scenes expressing a single theme, or a lot of sentences that are about the same thing. Rotoscoping is a method of tracing filmed or videotape movements to create natural motion in animation. It was invented by Max Fleischer in 1917. The Fleischers held the patent for both the machine, which Max invented, and for the technique of rotoscoping itself. We used rotoscoping to trace an image sequence of a greyhound running from Edward Muybridge's sequential images. So squash and stretch is one of the 12 principles of animation. This will make a shape change to follow the direction that it is moving and flatten as it lands. The volume will stay the same. So if it stretches longer, it becomes skinnier. If it becomes flatter, it also becomes fatter. This makes an object appear to be moving naturally. Another one of the 12 principles of animation would be anticipation. When the character is about to make a move, he pulls back to collect energy like a cat crouching before leaping. So the string, the blue string at the bottom, would be anticipation. Whereas the purple ball, of course, is squash and stretch, and then explode. Staging is another one of the 12 principles of animation. It involves composing your stage, your area, to draw the attention of the viewer to find the important details using the placement, the lighting, the color, and Gestalt principles of design to arrange the space. So it's basically just composing your space, making sure the viewer knows what's important. Straight ahead animation, you've got additive, subtractive, and manual. Remember we did the additive animation, the subtractive animation, and the manual transform animation with the A, B, and C. And that was straight ahead, where we drew each frame and just adjusted each frame, or used the computer to do it automatically, essentially. Pose to pose, once again, you calculate the time of the move. When does it start? How long does it last? Where does it end? And the number of frames needed. And then the beginning of the move is drawn, the ending pose is drawn, a position in the middle is drawn, and then you would use onion skinning to finish the sequence with in-betweening. And once again, there's the bunny. Follow through and overlapping action. You've got the motion of the character or object shown as layers of fluid motion occurring at the same time, but with slightly different timing. And when the main image stops moving, the parts may continue, and then they will return like hair on the head of a character as he stops running. Now, ease in, ease out, or slow in, slow out. You see you've got easing into the station, because this is what we have to think about with After Effects. So ease into the station, it starts out quickly and slows down. Ease out from the station, it starts slow and speeds up. So that's the ease in, slow out. Arcs, animals and people will move in curved paths. So when you're walking, your head bounces up and down. When you're running, you kind of lope along and your head goes up and down as you're running. Your body moves up and down and it turns into a sort of a curved path. Secondary action, your eyes will blink, your feet will tap. Living creatures move their bodies in different directions all at once, and simultaneous actions will make it look more realistic. Another one, timing. The real world has realistic timing. Things can only happen at a certain speed. To make your animations more realistic, use your timing to organize motions and make it seem believable. So I was telling people in class last time that you've got to make sure that you don't have things be too very slow. Sometimes when you have an explosion, you want it to happen so suddenly that it only lasts a couple, 3 frames. But a lot of people were making it last for like the entire 5 seconds, which doesn't make it very, it kind of makes it look less realistic. There's a lot of slower speed now. They do the slow motion in action movies, and it's supposed to increase the amount of tension, but you have to make sure if you're going to do that, you slow down the sound as well. You've got to make it synchronize with both, and often I think they overuse slow-mo, so I think that reduces the amount of impact of having a slow-mo to begin with. Exaggeration. When you use exaggeration skillfully and in careful doses, exaggeration can add humor, liveliness, and improve the impact of your message as well as draw the attention of the viewer. So whenever you see a cartoon animation where the characters' faces change shape or their bodies stretch out a lot because of something that's happening, they want to exaggerate what's happening to make it more amusing. And then there's solid drawing. Good artistry and an understanding of visual principles like perspective and relative scale and how to draw convincingly. In other words, this is why you need to take drawing classes. This is why people tend to have a lot more skill if they've done, say, figure drawing, and that tends to translate into whatever else they're doing. And the last one, of course, is appeal, giving your drawings character, personality, and the appearance of emotional depth. So this is my example of appeal. But not all of your characters to have appeal doesn't necessarily mean that they're cute. Sometimes appeal means that they have a realistic personality of evil, say like Cruella de Vil, or the crocodile in Peter Pan. You have to have some kind of a sense of the force of life, and that's the appeal. Shots composing the frame. So remember we talked about shots. An establishing shot is set back from the characters to show enough information to set up all the basics of the situation, such as where it takes place and what is happening. Medium shots are closer and more intimate and allow the viewers to hear dialogue and see details of action. Close-up shots are very close, and they will show a lot of detail of the action and the expression. So I've got an establishing shot, a medium shot, and a close-up shot. So you can see the difference of the character's appeal at each of those levels. And of course in the establishing shot, you're not really aware of those people as people, they're just shapes. An extreme long shot is a type of establishing shot where the landscape and the surroundings of the action are shown. You don't necessarily see characters at all. A long shot is an establishing shot, which is also known as a wide shot, from a viewpoint far enough away to show the location, subject, and action, and it may also include characters. A full shot refers to the full length of a figure. So you've got a person in this shot. It shows their entire body from the head to toes. And it allows dialogue and emotional interaction, but it's not as personal. Medium shot, you see the characters from the waist or knees up, showing facial reactions during a dialogue scene, and this is very useful for 2 or 3 persons who are in dialogue. A close-up shot, you've got the character's head and the shoulders, and this can be used for dialogue, especially with cuts between characters. An extreme close-up shot is a very close view of a person's face or of individual features, or some crucial object like a doorknob or a clock face. It heightens the tension and it focuses the viewer. A lot of Hitchcock dramas use extreme close-ups for objects like clocks and doorknobs. A single shot is a basic shot of one character, which is usually a medium shot or a close-up, and a two-shot is one of the shots with 2 characters in one frame, usually in a conversation. Now for composition and design, you want to remember it's important how you organize your space. And one of the ways we talked about organizing the space is to use the rule of thirds. It's a general theory that divides the vertical image plane. It's a general theory that divides an image plane into 9 equal zones by placing 2 equally spaced vertical lines and 2 equally spaced horizontal lines. And then the artist will organize the objects in space by arranging the image using these guides, either to locate things along the lines or the intersections, or somehow relate the objects to the grid structure. In photography, film, painting, and other fields, they often use this theory. And this is a painting by Edward Hopper here. And you can see how he's organized the space. It really does use that kind of rule of thirds idea. Other design theories that you can use: dominant versus subordinate, using placement, size, and relationships between objects to tell your audience what is important, how it is related to the space and to other objects, and what your animation means. The larger objects will be seen as more important. So you see you've got a big red triangle and a big white circle, and then you have a black zone and a white zone. The objects in the foreground have more importance than objects in the background. So things that are overlapping you see is more important than things that they're on top of. And dominance is determined by the size, the shape, and of course the triangle is dominant over the circle because it is a sharper, brighter red, stronger color, stronger shape altogether. The depth, texture, density, and you can see that that line down the middle where the black and the white connect has more objects near it, and so there's a denser arrangement of objects. The saturation of the colors, that red is extremely saturated, and the orientation, the angle of that triangle points down into the circle. It cuts across the entire composition. It points towards the corner. So it's very strong. So, well, it's an El Lissitzky poster from the Russian Revolution. Color theory, you've got warm colors, magenta, red, orange, yellow, that will come forward visually. You can see that here. The red and the yellow and the orange are coming forward. And then you have the cool colors like green, blue, and violet tend to recede. So that blue is very calm and it's very, very receding behind, and that's the sky. There are warmer hues of green and cooler hues of yellow, and colors can be warmed or cooled by mixing with other hues. Very saturated colors come forward, and you can see the very saturated red-brown of the bowsprit comes forward. Reduced colors, reduced shades recede, so you can see that there's sort of a very weak-looking brown in some of the lines in the back, in the middle. While pale tints of colors may recede, but when placed next to darker colors will come forward. The comparison with nearby colors determines the color effect. And Joseph Albers is an important theorist on the use of color in art. And he did have this really interesting book that I'm sure everybody has heard of about color theory. Okay, so Gestalt principles. You got your figure ground. The figure is the positive image, the ground is a negative space, white space. So you can see this image as two people silhouetted against a window looking at each other. Or you can see it as a vase. So the ground would be the negative space and the white space. So the black becomes this strong shape, it becomes a vase. Equilibrium. Every psychological field tends toward order, balance, and maximum efficiency. So your mind wants to balance things. If something is not balanced, it's not like a mirror image, your mind tends to try to find where it's not balanced and fix that. Isomorphic correspondence. This is another Gestalt principle. People are reminded of their physical or psychological experiences by images that trigger the memory. So symbols and shapes that recall some type of information from their background or past. And I often will talk about traffic signs and lights, which have a very specific meaning, and we learn what that meaning is, and we react to it emotionally and viscerally when we see those shapes and colors. Closure, we have a natural tendency to close gaps and complete an unfinished form visually, such as pliers, a gate in a fence, the opening in the letter C, etc. So you can see this is actually being a figure even though there's a lot of it missing. Proximity, closer shapes will form groups by visually uniting, so they look like they belong together. So you see this group of people in one corner and then everybody else is kind of just separated across from them. Continuation. A straight line or a curve like an arrow will start your eyes following, and you will keep looking along that direction until something else stops you. So you see the arrow pointing, and you see that as the direction that this person is looking, and you follow that arrow. Similarity. Identical objects will be seen together in groups. Similar objects are defined by shape, size, color, and direction. Sports uniforms use similarity so we can tell the teams apart. So here you've got the red team and the black team.